This presentation will be a multi-part series regarding analog transmission circuits. I will cover DX, which stands for duplex, and then two-wire E and M, and then I will discuss a little bit about the four-wire SF type circuits. I may at the end discuss slightly some DS1, T1 type technology, which is a digital equivalent, and there's an enormous amount of DS1, DS3 information today because that's still a currently used format. I have a book here made by Tellabs, and this book specifically dealt with analog type transmission and signaling. It does not cover any of the multiplexers that was used in the analog system, only the analog trunks that would normally connect to it. These do appear on eBay from time to time, and if a person has any interest in learning a better understanding of analog voice transmission and signaling, this is an outstanding book to use. It's kind of designed to be a training book. It's a very simple overview. Telephone sets are generally two-wire sets. There is an exception to this rule, but we will not be covering that in this video. Telephones in your home or business does not generally have the ability to be amplified. Now, in the world that we're living in 2023, they do have handsets that can be amplified. And back in the Bell System days, they also had handsets that could do amplification. But that was not a common everyday thing on every single phone made. Inside of these telephones, as well as some of the early phones, would be a network, or if it was the 300, 400 series phones and earlier, an induction coil. An induction coil is designed specifically for the telephone application, so you have your transmit and receive somewhat separated depending on how they intended to use it in the phone. Touchtone phones wire, of course, much differently than rotary dial phones, and then in the 300 series phones, the transmitter was in series with one side of the induction coil, and then the receiver had dry audio going to it. And there's a lot of information on single line phones. It's not possible to amplify a two-wire circuit in its native state. You can only amplify a four-wire circuit. So if you was to have a circuit that was very long and you needed to amplify the audio in either direction, one of the things that would have to happen initially is you would take the two-wire circuit, connect it to some transformers, better known as repeat coils, that would convert it to a four-wire circuit. Once it's a four-wire circuit, you can put an amplifier in series with each direction to transmit and receive. So it would require two circuits of two-wire to four-wire, an amplifier, and then a four-wire back to two-wire. At that point, you have control of the audio both directions, so you can increase or decrease the audio depending on what you're trying to do. If it was connected to a digital transmission system of some type, the amplification can be done in the channel unit before it is converted to digital, because once it's a digital signal, there is no amplification capabilities at the digital level, only at the analog level. If you're looking at a DS1, they do have what's called a DSX build-out, and that changes the amplification of the digital signal slightly to compensate for long wire or short wire, depending on the setup of the central office. Once the signal has been amplified, they convert it again back to two-wire. If you was to build a circuit, shall we say, from one side of the United States to another, then they would convert it at one end from a two-wire to four-wire, then it would be 4-wire all of the way through the system until it reached the far end, and then there it would be converted back to 2-wire. Each time you do a 2-wire to 4-wire conversion, then you have all kinds of issues that you can get into: feedback, echo, distortion, and so forth. Even with just regular 4-wire amplification, you'll have distortion, because every time you amplify a circuit, you introduce noise to it. And depending on how long the circuit is and how much gain that's being needed, you're also increasing the noise, as well as the power supply noise, and it becomes very complicated very, very quickly. And in order to build a circuit from one end of the United States to another, they would take many days to wire it up, and many people in every central office to do level adjustments so that you had a good talking circuit between two endpoints. And of course, there were so many other things that went into that as well, which is far beyond the scope of this video. If you're liking any of these videos, please subscribe and give me a thumbs up. I would appreciate it. When you get into trunk signaling and trunk connections, generally they use 2-wire to 2-wire or 2-wire to 4-wire if they want to amplify it. And then the signaling is done in various methods. One of them is what's called E and M. E stands for ear, M stands for mouth. This is to control relays from end to end for on hook, off hook, or supervision, depending on the type of a trunk and what the functions are. If this was an SF circuit, you would have the E and M controlling an SF unit. Then the SF would be going over a non-metallic circuit to another SF unit and then put back into a copper circuit. This was done so that you could have microwave radio and other types of carrier where there was no DC control across the carrier. It was just simply an amplified circuit, and then they would do the signaling in band or out of band depending on the type of a carrier system and the trunks connected to it. I've drawn a very quick 2-wire across the dry pair to 2-wire. There's no amplification at all in this circuit, and also there is no signaling between both ends, such as the one on the left or the right. If this circuit was designed, the telephone on the left end could talk to the phone on the right end, but there was no way of signaling the one on the right end, and the same, the right one had no way of signaling on the other end. Generally, this would be useless. However, this is the theory that was used on the 2 wires and side circuits. So you would have this circuit plus another set of coils to gain the 3rd circuit. But this is what it kind of looked like, and this is the schematic. So you would have the relay that would feed power to the phone on each end. I will show the actual schematic of the 2 side circuits in the Phantom. Then, in order to do signaling across this, you would then have to do an E and M type of a unit, and I will show that below this next. Please keep in mind this is all very elementary and simple. I'm not trying to make this into a 9-week course. Alright, I've shown the E and M. The M lead has negative 48 volts connected to what is referred to as a resistance lamp, and then a relay at the far end. So the resistance lamp plus a contact closure that would be happening over here, which would be an X in the modern schematic world, would operate that relay that was at the other end of the circuit. That would then, of course, could use to ring a phone, signal an off-hook condition, or control whatever it was designed to control. When the far end, such as the telephone trunk on the right side, was to acknowledge an off-hook condition or wanted to signal the opposite direction, then it would supply through a contact closure, through a resistance lamp, which I've already actually shown a resistance lamp and contact closure, so it does the same thing. It doesn't matter kind of where it's at in the circuit. Again, this is just a simplified overview. Would then operate the relay on the left side, and then again that would go off hook or ring a phone or whatever it was intended to do. Generally, in an idle condition, neither one of these would be signaled, so there would be no current flow in either direction. And then off hook, then the M lead, which stands for the mouth, would then initiate the seizure, and then at the far end, and it would go off hook and let the E relay down to say, yep, we have a completed circuit, and to close the loop or do whatever it was intended to do. This is all set up as a type 1, and there are many different types of E and M, and I will not discuss that in any detail as the switching systems or the trunks progressed. They went from E and M type 1, 2, 3, up to 5, and each one had its own purpose, and they worked fundamentally the same way. It just they did a couple other neat little things in the middle. Throughout some of the videos, I will show some of the different types of equipment that was used for multiplexing and transmitting phone calls over copper. We're looking at a 2 side circuits and a phantom composite signaling item. It takes 2 of these back to back, and you can put 3 phone calls with signaling over 4 wires. This generally worked on the open wires that would be running along the roads and through the countryside. It was built similar to the railroad signal system pole line, and I do not yet have this working, but in the future I will. This way I'll be able to have 3 phone calls over 4 conductors with signaling. There is no amplification here, and there is no 2-wire to 4-wire. I would discuss this on its own video in the future after I have this working. Here is some of the SF units, which stand for single frequency, 2600 hertz. I have several of these. These are not yet online, but I do have a few in a video that I made that's on my incoming selectors. The units in front of us are toll subscriber lines. This allows a single line telephone without a rotary dial or a touch tone pad to be connected to a long distance telephone switchboard. The coil that we're looking at in this particular case is what is referred to as a repeat coil. And these are the same coils that's used in the 2-wire to 4-wire. In this case, there's no amplification, so what that coil does is provide talk battery to the telephone set, and then it's capacitively coupled for the operator and the operator's telephone set, which is effectively a single line phone, has its own talk battery, so you're able to talk between 2 telephones and there's isolation between the 2. And this coil, which is in every circuit of 2-wire, 4-wire, 2-wire, 2-wire, and many 2-wire trunks, has the same functions. There's 4 terminals, or 4 sets of terminals, or 8 terminals actually. So you have transmit, receive if it's set up that way. 2-wire in battery feed with capacitors and all kinds of different ways of configuring these coils. Of course, if it was a 4-wire circuit, there'd be 2 coils. If it was a 4-wire to 4-wire, there could be 4 coils with the amplifier in the middle. These are 2 different types of Western Electric central office trunks. The top one is called a 2-way composite trunk, and then the bottom one is an outgoing composite trunk, which means they're outgoing E and M. One of the ways you can tell is here's the transformer I was talking about, the repeat coil, and here is the resistance lamp. Both of these trunks have a resistance lamp, as well as a polar relay and capacitors and so forth. The top trunk does not have a repeat coil because that would be part of the carrier system or the two-wire side circuits in the phantom that I've just briefly shown. Here are some different types of E and M trunks. This is a selector level outgoing E and M trunk, and there is no repeat coil on this unit, as that would be part of the channel bank or whatever type of a carrier that this connected to. We're looking at what's called DX signaling units. These are duplex signaling. The brown things are resistors, and then below that is the polar relays. These, in order to make a DX circuit, you would have one pair of these, one at each end of the circuit. There'd also be some capacitors and repeat coils between this and the cable pair. The repeat coils that would be part of the DX signaling circuit. In this particular circuit plate, between left and right side is 3 sets of circuits. So in order to have a DX signal working between 2 different locations, you would need one set of coils and capacitors at one location and the other set of coils and capacitors at a different location, wherever the DX unit was. One of the additional things they did use the DX stuff for is if you were in a very large central office and you had up to 1,000 or more feet of cable between the mainframe and the switching equipment trunk, the E and M may have to be repeated, and they often use DX equipment to do that. They only repeated the E and the M, not the voice part of the circuit. This is a channel card from a Western Electric D4 type channel bank. This is a 2-wire E and M. This card has the repeat coils built into it, and this is the card that takes the analog voice side and the external E and M and then converts it to a digital format. In this particular case, you're converting a PAM signal, which is pulse amplitude modulation, which is the analog side, into a PCM, which is pulse code modulated, which then of course becomes a DS1/T1 type of a circuit. This is one channel of a T1, which would be a 24-channel circuit. So in order to have 24 trunk connections, you would need 24 of these cards. Generally, at the far end, you would have an alike card or a 4-wire to 4-wire card. Of course, there was a lot of different types of cards made for different types of trunk configurations, and that is far beyond the scope of what I intend on making a video about. Here's an actual Telabs card. That is a 2-wire to 4-wire card. This is some of the cards that would be shown in the book that I begin the video with. This was a compact design where you have kind of the 2-wire, 4-wire thing in one circuit board versus a very large relay plates with coils and so forth on it. This was a card that was made in the late 70s and early 1980s. Here's some of the Westcom and Telabs type cards that I have, and I have a whole bunch of different cards that perform different functions. This is all 100% analog technology. There is no multiplexing being done in this equipment. It is just simply 2-wire to 4-wire or amplifiers, or what they would refer to as a term set. I have 2 systems of Western Electric O carrier. This is a 16-channel system that puts 16 voice calls over a 2-wire circuit. The equipment here does not amplify anything. All it does is channelize it. Depending on the type of filters You could have 4 of these terminals, which we're looking at 1 of 4 terminals combined to make a 16-channel system. Once you get the 2-wire, which is not showing, but here's the term sets down below, and I have 12 term sets. That is how they convert the 2-wire to 4-wire, and then the E&M is done at the trunk, as I showed earlier on. So in order to have 16 channels on 2 wires is a 9-foot tall relay rack for approximately 12 channels, and then the next 4 would be in an adjacent relay rack, and of course there would be a few other odds and ends. Back of the O carrier. This does have 3700 Hertz SF built into it. This was one of the few carriers that did use 3700. Generally everybody used 2600. However, if you were running back-to-back units or going into other systems that did not have SF built into it, you would disable the 3700 Hertz oscillator, and then it would be, you'd have to use a 2600 type circuit going across this. The trunks we're looking at is part of my number 3 crossbar switching system. These were originally set up as 2-wire E&M, and they have been converted to 2-wire loop trunks. I have here a schematic of a very simple outgoing E&M trunk from a selector level in a step-by-step switch. It does not show the repeat coil because that would be part of the carrier channel unit, such as a term set or a channel unit like the D4 channel unit. Of course, they had in the digital world D1, D2, D3, D4, and D5 channel banks. I've seen D3, D4, and worked on D4 and D5 in my career. This here can be set up to a duplex trunk or of course a carrier, and if I wanted to connect 2 of these back to back, the proper way would be using DX equipment because they were not intended to be connected to one another without some type of carrier stuff in the middle. This is a more a very simple trunk, and you got the audio coming in, and then you have the different types of networks, relay coils, and then the resistance lamp and so forth. I don't intend on getting into how the trunks work from a technical point of view, other than here's a battery feed circuit to provide current to the telephone, and then the repeat coil would be connected over here, and then we have different parts of the signaling stuff, and then this goes to the selector level. These are, again, very elementary trunks. They become very complex when you get into the 2-way equipment, and then different types of ANI trunks and so forth. And those trunks are way out of the scope of my video. This is the end of part 1, and I will, in the very near future, make part 2. Please like, subscribe, and make comments. Thank you.